Okay, so we are talking about different aspects about digital transformation, about the data, and how to apply to PV industry, the PV data flow, the digital trade regarding the PV manufacturing, and finally our BIM approach and our digital twin as we do it with IESA. But I will explain you more detail. Okay, what is digital transformation? This is a vast topic, vast subject. As you can see here, we have three different aspects. We have digitization, digitalization, and finally, the digital transformation. The first step is the conversion of your product or your process into uh, digital media. Uh, you know that from the past about 30 years ago, we start to design by CAD system, computer-aided modeling. And this CAD system is a first step of digitalization because we start to convert the product description, the engineering description into digital file. Digitalization is a process. How you transform this process into a digital process and you start to do business within digitalization process. And digital transformation is a holistic aspect of digitalization. That means the way you will be working will be based on digital offer and everything is connected together. Okay, why digital transformation? According to IDC, International Data Corporation, the global spending on the digital transformation is forecast to reach about almost 3 trillions in 25. So it's very huge amount and more than double of the amount allocated in the year 20. And this include all everything, new ways of working and delivering value to your customer, enable efficiency optimization, support business challenge, create business opportunity. This is a broad business strategy applicable across all industry. What I have just a comment. For example, yesterday, all of you presented different PowerPoint and information about your development, your innovation. All these things could be stored in the same database and linked to the product in the near future. So this is something that concerns everybody. Unfortunately, what I saying today is not related directly to the PV industry, but it concerns every aspect. So the first step is the digital product I said before, and second step, digital process, then the digital business, and of course, finally, the digital enterprise. Why digital trade? Digital trade is a continuity of information from A to Z. That means if you start to do digital collaboration or work today, all your data resides in multi-operation domains, and you have what we say multi-source of truth. The goal is to link all these to the continuity digital trade together in order to offer a single source of data truth. This is the main goal of the digital trade. As you can see here, I go back in a little bit in our story with what we call discrete manufacturing, like car, aerospace, and so on, where the geometry is very important aspect. In this case, in the past, the people, the industry design what they call a master model. The master model is somehow a physical model that is the reference of information for all the different other activity that coming afterwards. And today, the master model is no longer a physical model, but it's a digital model. And for example, I give this example again. You can see here with the mouth of your laptop, you start to design it using CAD system, computer aided design, and you learn about what we call the PLM. PLM include all the different activities concerning the analysis, the quality control, report, and monitoring of the mouse design and fabrication until the realization of the physical object. And this physical object today can be in parallel represented by a twin, a digital twin, connected to the reality with sensor, as you can see further on, and we can simulate and monitor the behavior of the real object in order to predict the maintenance and whatever different activities that follow this operation. So get back to the PV, solar PV panels. You know that the solar PV industry today is dominated by China. The trend of China is currently the cost is very low, and China currently invests 50 billion. What I discovered in some reference document, that means 10 times investment in Europe. And China export almost 30 billions in 21. So maybe Stockton can check if I do not say some mistake about that. But the weakness, and this is very surprising for me, the industry is very energy intensive, and the energy used for China manufacturing plant, they are almost based on coal. So it's a bit contradictory. So the European challenge today is manifold. First, to ensure about the supply chain vulnerabilities, of course, about the cost competitiveness against China, and last but not least, about the environmental aspect. Because if you want to fight against the climate change, I don't think that this process is so good for us, for the planet in the future. And okay, well, we know that labor and tools in Europe are not getting any cheaper. So we have a hope that digital technology can help Europe industry to localize this industry and to decrease also the cost of manufacturing. And the last one also, we discover that the digital, the PV solar panel industry today will be very linked with the construction industry. So I think that this integration with the building sector, we call it AEC, Architecture, Engineering and Construction, based on the BIM process, Building Information Modeling, could help to boost the PV solar industry. Okay, so what are digitization and digitalization in action? For the discrete manufacturing, as you can see in the upper part of my slide, you have the IT technology. IT technology include the CAD, PLM, BIM, IoT, augmented reality. All these technology are powering digital transformation of the industry in all sectors. For the solar PV industry, which is classified as a semiconductor manufacturing process, this process is not characterized by the geometry, as I said before, but by the moon-type operation and the component-based planning. I will go back later. That's why I think that what we call the production planning and control is a very important aspect in the PV, the solar PV development industry. Give you a little bit more detail. To manufacture the PV panels, you know better than me. First, you have all the chemical process or physical process about lamination, about materials, and so on. And after you have industry of assembling all the components into the panel. So it depends very much from the machinery, all the different special machine to do that. And the last aspect concerns the construction, how to install it onto the building or other infrastructure. So you have many different components to be assembled along the life cycle of the PV panel manufacturing. Okay, I go a little bit faster. So you know that all the data today are the key issue of every activity or business. Concerning on the left side, as you can see, when we start to design CAD system, we get data. But this data help us to transform into information and finally into knowledge. On the other side, if the IoT advanced, we can also get unstructured data. You have the difference between the left side and the right side. On the left side, you have structured data. Structured data, that means the data coming from the physical behavior equations. And on the left, you get the data, live data from the operation of the system. And we have to transform this data into pattern of information in order to extract the information and the knowledge, relevant information and knowledge. And what we are developing today concern both aspects of the digitalization process. Okay, the PV data flow, as I said before, about the PV value chain. First, you have many different process coming from the chemical, physical aspect. For example, yesterday, this presentation was made by Synthes, and I think that all this information can be attached to the PV panels in the next step. Globally, the digital threat will come from your file, for example, as you presented yesterday, with the component also about the different device, different component presented by IREC or COSILAB. All these components are used to be assembled and then to mount onto the infrastructure, and so finally we get the digital twin. And the digital twin ensures that all the information will be attached together. That means you can access to any information wherever you want and whenever you want. This is something that we believe that in the future is very important for retrieve all the information. The main stage of the PV process, as I said here, you have upstream process during the manufacturing of the PV panels and the downstream process regarding the EPC at the link to the building construction, engineering, procurement, and construction. In our project Super PV, we mainly concentrate to focus our activity on the downstream process. Today, we do not attach so much our information, our digital twin with the upstream process, but it's scalable. That means we can allow you to give us your information to attach to the same database. So all this, that means we have three almost 3 different databases today that we can link together. You have regarding the PV cell, the PV panel design, then the PV panel manufacturing. You have this vertical process, and finally, we can have the PV plant process. The example I will give you concern mainly the PV plant process that we have developed within the Super PV project. Okay, digital twin. Regarding the digital twin, you know that we can classify digital twins, mainly the different digital twins, in 3 categories. One, the category we are focused in CAD-CAM is the prototype, the digital twin prototype. Concerning the digital twin we got from the PLM, from the design of the object. And you have also the digital twin instance that IESA will present to you, concern the collection of real-time live data from the object in operation. The digital twin instance, as I said before, could concern also the machinery. It's not our subject today, but of course, for the manufacturer, they can also develop a digital twin instance concerning the machinery during the manufacturing process of the PV plant, the PV panels. So, how today our development are based on existing software for the market. For example, here you can see here you have Revit. Revit is a BIM system developed and proposed by Autodesk. And why we need to develop the digital twin? Because I think you will see within this unique single platform, we can of course offer the NCOE estimation. We can visualize also the energy opportunities, let's say the energy potential of energy, solar energy we can get on the bonding, on the envelope of the bonding. And of course, we can also predict the different behavior of the power plant in the future. So I believe that today the digitalization is essential to enable the massive deployment of photovoltaic in our smart city, as we said today. And this is something that we can allow, if we talk about training, digital twin can also be a very interesting tool to train people and to define new job profile. Because I think today, most of Department of Education in any country, they are thinking about how to define the different curriculum of the training in the future regarding solar energy. Of course, in Switzerland, they have a task force to decide to think about that and to explore the different training they must offer to boost the solar panel installation. Okay, so to resume, within the PC Super PV project, we mainly concern the 3 aspects, as you can see here. We get information from the PLM, we store it into the same BIM database to explore the EPC, to give a tool for the architect and to energy engineer, architect to have a conceptual design how to install PV panels for their building, and experiment energy engineer to clearly design the PV panels on the solar roof and so on. And of course, the last one is to connect with the digital twin instance to offer a comparative table about energy performance between the calculation and the real measure. So, as I said, the digital twin and the digital tree as a foundation for the digital transformation. Okay, I think it's not necessary I go so much in detail. This is to explain the different relationship between the three database we are developing, and we are developing mainly connections interface between the three database. This is our software, the middle one. The software tool coming from ISR. So we have developed a data exchange mechanism, and we get the data flow from Syntef regarding the quality control and so on to define the us design PV panel information. I don't know if it's clear for you. If not, you can interrupt me. And okay, let's see. Here's a different step, as you can see. But it's better thing I can give you the video. It's more explicit to understand. It's a different step, as you can see here, and within the same platform, we offer you to perform the cost calculation, NCOE, and the capital expenditure, the CapEx, and finally, the digital twin connect with the platform in order you can get the comparative feature and so on about the energy performance. Okay, let's go to the last one. What I explained you today, you can just to not forget to you have a very good article written by Erika and the Subsea team and us. Everything I explained in this article, you can see it. And another reference for me regarding the material and manufacturing of digital or PV panel process concerned as this. I refer to this article, planning of flow of material and energy for photovoltaic industry. It's very interesting article also to explain how to do the manufacturing process. And now I will share my screen with the you don't see my screen now.
We cannot see your screen, just Sala America. I guess you need to share it again.
A video. Share it. Okay.
Yes, now we are. Yes, now it's good.
Okay. So you can see this video, we are preparing to present it next week. Okay.
Sorry, but the video is without noise, right?
No sound.
Okay, good.
Only it's a silent video. So, but I can comment here. Here is our platform with our beam solar calculating the energy produced, expect to be produced by the sun on your building. This is to explain the different relationship between the manufacturing, the PV plant, and the PV plant monitoring. And all these things are linked together within our platform. So the building can come from the BIM software like a Revit, and we can import it into our BIM solar, and we calculate the different energy produced by we can get data coming from the meteorological institute, and we can calculate the potential of solar energy. And we can help design engineer. This is a Revit system. We can install PV panel on that and do the connection with inverter and so on, as you can see here. This is a layout of the PV, and we have a database of almost all manufacturer PV, and also we are introducing also inverter and the different components also. So the design engineer can design everything using this software. And here we can calculate the cost estimation and COE as the CapEx as proposed by IRH. And so this one is concerning interface of our digital twin. We can get information from AESA. We will display it here. It's near real time. It's not real time. The real time is done by AESA. So this is the different, because you know IoT is a nightmare for us. Okay. If you have a question. Of course, in the future, we can more closely link the digital twin instance from AESA with ours. But today, there are different issues about the interface, so we prefer to disconnect the different things today. But for sure, I can explain you because IoT is, for me, it's not enough, a stable technology enough. We have electric bike. Connect with mass platform, and it's a nightmare for me because every morning I want to start the bike, I cannot start it because somebody has decided to authorize me to. So it's very complicated. Okay.
Thank you very much for your talk.
Any question?
Other questions from here in the room or from outside?
I just wanted to thank you because the presentation was very clear and comprehensive, and the tool that you presented is super interesting. So thank you for your presentation. I really enjoyed it as a listener.
What we hope is to link all your work together. Please, we are not expert of PV panels manufacturing or design, but what you did yesterday, for example, I believe that we can bring all these files, Word file, Excel file, whatever, to link together. And one day when you click on the PV panel on our digital twin, you can get all the information. Who did it, who developed it, who innovated.
No, it's a very powerful tool indeed.
This is the main goal. Okay, thank you.
Other questions outside here? I just see the shared screen, so I don't see anything else.
No, I don't see any question coming, but maybe we should wait a few seconds. And if not, we can continue. Thank you very much for your presentation. Was really, as mentioned, it was really, really clear.
I have one question then. Did you check the forecast with the real output data? So how close are those?
I forgot to show you because I want to go a little bit faster, but I have this slide.
Ah, cool.
If we,
I think it's an important slide, you
Yeah,
know,
yeah.
otherwise
yeah,
all the simulation
Yeah,
may be just for fun.
if I can share again.
I guess the connection in Sala America
Yes.
is not running.
Oh, really?
I had to
Yes.
come to go. I don't know why. But if we have time, I can show it quickly to.
We have enough time, no worries.
Sorry, the connection in Sala America is not good. We are not being able to see you. I mean, we see you, but really slow also with the audio.
Ah, okay. Do we know something? What? No.
Now it's
Hopefully-
better, but it was
Okay.
frozen for,
A few seconds, minutes.
yeah.
Personally, I have to connect again. I don't know why. I was.
Maybe because of the low connection, you were thrown out. Yeah.
Okay. Okay. Can I share my screen again, please?
Yeah. Ah, Yasmin?
Yes, you are able to do it.
No?
No, now?
Yes, okay.
No, no.
It's frozen. And now, yes, now. Sorry, but the connection is not really good, I guess, with Sala America. It's getting a freeze and we cannot hear you.
Okay.
Okay, so
You don't hear me, Yasmin? Obviously not.
Yeah, now I do, but it's yeah, it's getting freeze.
Going up and down, okay.
Yeah.
synchronize again.
Maybe if Claudia can help again.
I don't know. Did you share the PowerPoint window or the full screen?
Uh, okay, let's hope it pleasant. Okay, here you can see equation we use from IREC. We integrate the interface and here, okay, is the result about the cost reduction. Okay, you can see it. We estimate that we can allow 14% to 50% of cost reduction. This is historical. We cannot say that we have checked it. About benchmark with other systems, most of the installers today use PVCs. I don't know if you know this system. And this system was developed by our colleague in Geneva, the University of Geneva. And we have made some comparative with the system. And today, as you can see here, The yellow one is PVCs and the green one is super PV, our calculation. And we are roughly the same value. So the difference is very small. So we can say, okay, our calculation are good enough. The difference between our system and the PVCs, our system is fully beam integrated and not PVCs. The calculation are not exactly the same. PVCs is based on analogic equation, and super PV is based on a pure digital calculation. Maybe I can give you an example. I come from the mechanical engineering sector. All of you know the finite element analysis. Our system is based on ray tracing. Somehow it's a little bit nice, finite element. So we consider the building as a whole, and we use the ray tracing to calculate it. PVCs use the equation of energy transfer. So it's not exactly the same equation. So our system is more user friendly if you want, and as we are fully integrated into BIM, I think that we have a more perspective in the future with such a ray tracing method. Otherwise, the calculations, the results are almost the same.
And which one is the measurement? The gray one?
Yes, I think so.
So the measurement is always lower than what you calculated.
Yeah.
So
Yeah. Yeah, we
that
are a
might
little
be a
bit
problem
more
if you want to get money from it.
A little bit more optimistic.
Yes.
Yeah.
Okay.
Yeah.
And how much is that? I don't see the scale, so
I don't have
seem to
it,
be of 5 to 10%.
I can show you.
We're not able to hear you.
It's not saying something.
Oh, okay.
He was looking for something.
Yeah. Sorry.
So he was searching for something. And with that, he lost his connection to the screen. You're working on that.
Okay. I find the wall. Want to visualize the wall.
Okay. I think now you have to share again. There it is. Okay.
You can see it here.
Yeah.
So you can see is the percentage. The delta is about 6% maximum. 4% to 6%.
Which is difference between the measurement result and the simulation. Okay.
Yeah.
There.
So this is real production, about 5%.
And what is the main impact of this difference? why do you have this difference? What is the reason? Where is the main difference coming from the ray tracing, from the sun
but
simulation,
I think
or
it's
from what?
also the meteor data.
Okay.
Yes, the meteor data are more optimistic also.
Okay.
Yes, and our calculation also is a little bit more optimistic than reality.
And where exactly is this more optimistic in your calculation?
Yeah.
Where? So what do you assume more optimistic than it is in reality? Besides the better weather?
Yeah, I think the meteor is always a little bit more, more optimistic, and our calculation also, we do not consider also the collateral effect also. For example, we have to fine tune the different shadow and things like that.
Okay.
So, okay, this is the state of the art today.
Yeah.
Of course, if we want to fine tune it, we can decrease this optimistic consideration. We need to fine tune better.
Yeah. Okay. Good. Okay. Then I thank you very much for that. Are there more questions from others? Obviously not. Then I would like to thank you very much, Van Kai, for your talk and explanations. And I think we can go on maybe with Thorstein already. Would that be possible for you, Thorstein? Yasmin, do you hear us?
Yes, I do.
Okay. So maybe Thorstein got the coffee.
Yes, he should be able to hear you, but
In principle, yes. Okay, but obviously not at this very moment.
wait. Yes, he obviously doesn't hear us.
Yeah. Okay. So then I would say we have to make a break and try to get Thorstein.
Okay.
He is scheduled only in more than 30 minutes, so therefore he might have something else to do. But would have been nice to start earlier, but yeah, obviously not possible for the moment.
We can then make the break now, and
Yeah, then we make a break now.
He's now.
Okay,
He's in the chat.
Yes.
There.
I was here all the time, but I was not allowed to speak or show video.
Okay.
So
That's a pity.
that
So
would be
is it possible for you to start your talk now?
So I can. I'm happy to give my talk now.
Good. Thank you.
Okay. Screen. Do you see my screen?
Yeah. Full screen, perfect.
Okay. So title of the talk is impact of improvements on LCOE. I will first talk about assessment methodology for techno-economic performance, and then about improved operational PV power plants, effect on the LCOE, basically from two main variables, and one is how is the LCOE affected by reduced operational maintenance costs, and also how the LCOE is affected by varying performance ratio. And finally, third topic is from promising results in Super PV to commercial success, how to achieve that. So first on the methodology, the basic concept, and the first question will be, from where does the LCOE originate? And the basic concept to consider here is the net present value of a business case or investment decision. Because the net present value is the present value of all future revenues minus the present value of all future costs. And if the net present value is positive, a business case is considered to be profitable under the given assumptions, of course. The relation between LCOE and NPV is that the LCOE represents a hypothetical constant or levelized electricity cost at which the net present value of an investment in a solar PV facility is zero, which is the point at which the investment breaks even. And then one more slide on this for the specially interested. I also shown this before, but repetition is sometimes good. Anyway, the present value of all future costs and revenues are discounted at a discount rate equal to the weighted average cost of capital, which is dependent on the cost of equity and the cost of loan or interest rate, compensated by the tax rate. And the present value of future revenues in the simplest case is given by this formulation. Summation for every year, electricity price in every year, and annual electricity generation. And the trick here is simply to make an assumption that, of course, not is true, and that is why we call the LCOE hypothetical quantity. But anyway, if we assume a constant electricity price, which will be the LCOE, then we can take the electricity price out of the summation, because then it's a constant. And this also implicitly shows why future electricity generation must be discounted in order to obtain a correct formulation for the LCOE. So then at net present value equals zero, then we just set this equation here equal to the present value of all costs. And finally, then you obtain the expression for the LCOE. So that is basically all there is to it in terms of relation between net present value and LCOE. On the super PV, more concretely, for the third time, LCOE is the price at which electricity must be sold to the market to break even over the lifetime of the PV facility. And from this, it follows that a solar power plant will be profitable if one is able to sell the electricity at a higher price than the LCOE over the lifetime. And the economic performance assessment that we do of all prospective innovations is done by evaluating the impact on the LCOE from added costs, such as increased component costs from a new innovation, and benefits, such as enhanced energy yield and/or reduced operational maintenance cost. If the LCOE is reduced by adding an innovation from added cost and benefits, the innovation is deemed profitable, and vice versa. And the generic value proposition might be formulated like this: by using our innovation, you may achieve a reduced LCOE in your PV facility. I will just give one assessment example for an individual innovation, just to illustrate how we do it in practice. And this is, I think it was talked about yesterday by Damian. So the concrete example here is the module level power electronics smart box. Potential revenues from this innovation are both reduced operational maintenance costs and enhanced performance ratio. At the point of this calculation, we didn't know anything about how much reduced operational maintenance cost and how and the improvement in performance ratio. So then it's a perfect example for sensitivity study. And here we see at a given component cost of 0.04 euros per watt peak, which was an estimate in early phase of the project, we see that the window of opportunity is when the LCOE change is below 100%. So at the component cost of 0.04 euros per watt peak, you need, if you have no gains in performance ratio, you would need, in this case, an reduced operational maintenance cost of, say, about 12% in order to break even. But if you can have both improved performance ratio and reduced operational maintenance cost, then of course the profitability may be higher. Now over to second topic, improved operational PV power plants and the effect on the LCOE from reduced operational maintenance costs and performance ratio. First, OPEX includes both fixed operational expenses such as insurance, land lease, R&D, so on, and variable operational maintenance costs, operation of the facility, changing of components, cleaning of panels, and so on. And here, for the entire OPEX, state of the art at when we wrote the proposal for Super PV was about 20 euros per kilowatt peak and year. And here we see if we can reduce the annual OPEX from 20 to 10 euros per kilowatt peak annually, then you can reduce the LCOE with 0.8 euro cents. That sounds like a small improvement, but it's really not. It's a large improvement because in this case, the base case here is this is a calculation for a hypothetical PV plant in Spain, located the same irradiation conditions as in Sevilla. Assumed system cost 0.7 euros per peak, giving an LCOE at the base case at 4.9 cents per kilowatt hours, and of course 0.8 compared to 4.9 is close to 20% reduction. And then we have LCOE sensitivity versus the performance ratio. Just to repeat what that is, and by definition, the performance ratio is the ratio between the energy actually generated, the AC energy delivered to the grid, to the DC energy on an ideal lossless PV plant would have produced with the same amount of irradiation energy and at the module temperature of 25 degrees Celsius. For special interested, here is a hyperlink to a good report on that from the IEA PVPS task force on performance ratio. Anyway, here we see, we assume for Sevilla or Spain, base performance ratio about 85%. For Vilnius or Oslo, we would have assumed maybe closer to 90 due to lower module temperature. But anyway, if you are able to improve your performance ratio from 85% to 90, then you will could reduce the LCOE by a little more than 0.2 euro cents per kilowatt hour. So that was some quantitative estimates on how the LCOE varies with operational maintenance cost and performance ratio. So finally, from promising results in Super PV to commercial success. Of course, basics, we can look back to the Super PV proposal, where it was stated that the project aims to develop, integrate, and demonstrate a set of technologies for the new generation of PV systems by adopting technologies under development on lower TRL level into products on high TRL and MRL levels. TRL technology readiness level, MRL market readiness level. There are no quantifications in the proposal on MRL ambitions, but concerning TRL, the quantitative ambitions for innovations in Super PV is in general starting at TRL 4 or 5 with the ambition to reach TRL 6 or 7 at project end. In this box is this is actually the exact definition of TRL in Horizon 2020 program. So before we go further, I will just repeat one slide from a Super PV exploitation workshop we arranged last November in connection with the 42 months consortium meeting. Still relevant. Some important questions for key exploitable results with the commercial potential. Will the prospective innovation deliver as promised based on Super PV results, which of course is the entire task of work package 3 to 6 to find out? Do we have a clear IP strategy in place, such as patenting, secrecy, or other? What about share ownership in cases where we have more than one innovator in the project? Do we need to or to consult the consortium agreement, or is everything okay? Next question, do we see external changes concerning market or technology that may influence the addressable market size for the innovation positively or negatively? What is the TRL gap from end Super PV to commercial level? Commercial level is by definition TRL 9. How to finance the remaining development? And finally, are the important stakeholders for exploiting the innovation in place? Among those are, of course, commercializing party. Who will produce or take the innovation to the commercial at the commercial level? How will they earn money? First, commercial user. Do we know who that is? Beachhead market. What is the initial market? And in connection with this, what is the value proposition we offer to the end customer? And finally, sales, marketing, public relations. How are we going to tell the world about our fantastic new innovation? So that was from last November. Now back to the question from promising results in Super PV to commercial success, how to? So next question now is, what is the status at this point in the project, including commercial prospects? So we have, in the spring, we had the deliverable D74 intermediate risk assessment, where we did a risk evaluation for not achieving commercial success by breaking down this into specific questions, innovation by innovation. First, how are identified technological related risks influencing business case scenarios? For instance, are the results in accordance with accordance with ambitions? Have you achieved intended TRL? Do you have a need for new technology partners? And so on. Market-related risk. Is market dynamics influencing business case scenarios? For instance, increased component costs. How will that influence the business case? What about the increased interest for solar PV in Europe? Could that be a positive influence? And also in some, at least one or two cases, is the solution already commercialized by others? Question 3 here. Who will bring the innovation to TRL 9 after end of Super PV? Is required funding specified, identified, and have you thought about funding sources, such as at EU level, for instance, Eurostars, which might be a good source for SMEs? Is the commercial lead company identified? This is, of course, a crucial point. And we are happy to say that this is actually in place in most all cases. Are the first commercial users featured market identified? Is it maybe a Super PV partner? So what did we do with these questions on the assessment of each of these 5 questions here? Finally, a little bit about present and remaining activities from exploitation point of view and from work package 7. So BMW and Becquerel Institute, we initiated a process early August by approaching innovators and end users involved in the most promising innovations. So we decided to set a limit in place, and the limit was that innovations most promising are innovations that not at a high or critical risk level, and with TRL larger than 5. So what we wrote to them was an email contacting them in relation to the business plan development, and informing that we are now in the process of developing business plans. So what we did earlier in the summer was to create this business plan template, and we made an initial draft of the first part of the business plan for these promising innovations, and sent it to the innovators and end users. And these templates, this document contains a template for complete business plan, where most chapters at the point where we sent it to the innovators and end users was not filled out. And what happens now is that we are currently having dialogue meetings with innovators, end users, and also commercializing parties inside and outside Super PV to discuss and hand over this business plan document to the ones that needs to own it in the end. And that would not be BMW or Becquerel Institute. That would be the ones that should take the innovation to the next level. And that is actually the aim with this exercise, which simply is to assist innovators, commercializing parties, so that they have as good a starting point as possible for taking their innovation further towards commercialization after end of the project. So we are halfway through now. I think we have completed 5 meetings, and we have, I think, maybe around 3 or 4 meetings left. So that was point 3. My concluding remarks, to repeat what I have talked about. First, I presented the techno-economic assessment methodology in Super PV, and explained the relation between net present value and LCOE. Improvements in performance ratio and operational maintenance costs are targeted in many Super PV innovations, And the general effect of varying these two variables on the LCOE was presented and repeated here. Status on commercial exploitation opportunities was presented, and the key remaining activities from exploitation point of view are to finalize business plans for commercialization after Project 10 in cooperation with innovators and users and commercializing parties. The ones to take ownership to the next phase on the road to commercial success, and that is actually what we are seeing now. In all cases, so far we see that they actually take control and ownership to the business plan document and development, which is as it should be. So, thank you. Questions?
Thank you very much, Torstein. That was good to see. Are there questions inside, outside the room? Oh, questions. Okay. So all hope for the big business. Aha. Good.
So either you have understood everything or nothing.
Yeah.
Okay, good.
Okay, then I would like to thank you again. And I would suggest that we have a break until 11:15. 20 minutes, and then go for Ayesa. Talk and hands-on. Okay? Good.
Okay.
Then get a coffee and something and be back at 10:45.
Okay. Thank you.
Thank you. You.
The recording will still be on, so if you want to turn your camera off, you're free to do so.
Okay. Thank you.
turning the microphone.
Yeah.
Hello.
Hi, Yasmin. Hi, everybody. So we are back from our coffee break. And now we are looking forward to ISS talk and let's say hands-on training on supervising the PV power plant here on the roof of in Sevilla of ISS installation. So.
Okay. Hello, can you hear me?
Yes, we can.
Okay. So this part of the meeting is going to be in a different format. It is supposed to be a hands-on training workshop. So firstly, we are going as the training will be focused on Seville demo site. Firstly, I would like to show you our PV installation. As it is very difficult to access, it's not feasible to visit the demo site in person. We would like to show you a video that was recorded to show in the next week event in Milano. But I will please ask Jasmine if possible to share the video with the sound, because if I do it in my laptop, we will have
Yes.
problems with the noise.
Yes, I can. Give me
Thank
one
you.
second. I have it open here, so let me share my screen and let me know if you see it. Do you see my screen?
Yes.
Okay, good. So now I will. Is the audio okay? You hear it?
No.
Okay, so
That's very easy.
now,
Very easy.
now?
No. Well, the sound is not very important.
Oh,
Really.
okay. Okay, so then I will just put it like this.
Can you please put it? Yes, full screen. Thank you. Okay, that's our headquarters building. It's next to the place where we are right now. And this is where the demo site has been installed. We can see the panels, the sensor of dusting, and all the meteorological, the weather measurements, our analyzers, weather station. This is all the inverters. An overall view of the installation and the building. Just to give you an idea of the real installation. Thank you, Jasmine.
Yes, I will stop sharing now and I will allow the people to come in.
I will start sharing my screen right now. Okay, just to give you an idea of the access to the installation. This is how you access to the roof. Okay, so in Super PV we have focused on digitalization of the demo sites for operation and maintenance purposes. We have developed a framework of tools over the base of another development from previous European projects as NetFision.
And we have added a lot of features to focus on operational maintenance, as I have said. There are some different profiles that you can have to access the tool. We are going to enter with a general one. You can, if you have a permission to see all the demo sites, you will be asked to choose one or the general view. We will start with that. I want to focus this explanation on Seville demo site because it's the one that we have more features running properly. But to give you an idea of the whole platform, the idea is to have at a glance a view of the current situation of the demo sites. In the map, you have a summary of the current alerts that have been raised on each installation of each installation that we are right now monitoring, that are Seville, Oslo, Vilnius, and Orsasat. Toseu, sorry, that's right, Toseu. And we have some tools summarizing these demo sites. Below the map, you can access every alert and see the detail of each of them. And here you have a summary of the performance of the digital twins of the 4 demo sites, and here a summary of the production of the generation of the plants. There is also a graph of the consumption. This is only for Seville. It's the only demo site that we are monitoring some consumption in our building. It's not the whole building, only a part of them. But we thought it could be useful in order to make some calculations about the energy balance with respect to some consumption. Okay, so as I have said before, we are going to focus on Seville. So you can, this Rinconada, this is a PV plant owned by Ayesa. Or used to be owned by Ayesa, and we have started super PV developments in this PV plant, but it's no longer available. So we are going to focus on this 4, and especially in Seville. This is the landing page that an operator will see when entering as the operator of the Seville PV plant. In the 3D model, this is only a 3D model. It's not a whole beam model as Van Hai was showing, because our platform is not able to afford that complexity of graphs. But it's very useful in order to understand the alarms and what is happening in the PV plant. We can see the 3D model of the building with the panels. The red ones are showing some alarms. We have also a summary of the state of the building. There are right now 440 people inside the building. We are connecting to the present control of the system of the building, and also we are connected to the SCADA of the building, so we can manage the internal temperature of the building and also the humidity. And this is the suggested date to clean the panels. Okay. Regarding to what our colleagues said yesterday, we haven't cleaned the panels, never, to test it better. But in fact, we are going to see in a few minutes that our estimator states that it's not needed to clean the PV panels, never, because even if in Seville it's not very usual, the rain is enough to clean the panels, and the losses are not enough to compensate the cost of cleaning, at least for this small PV plant. Okay, so this is related to this part of the screen. At the right, you have a summary of KPIs. Right now it's cloudy at Seville, and it was very foggy in this early morning. You have a view of the performance ratio of the PV plant. The performance health, that is a relation between the digital twin, or what we name digital twin, is the machine learning model that mimics the behavior of the PV plant, that mimics the generation. So right now we have this percentage of accuracy, the availability of the whole system, the soiling ratio right now, and cybersecurity health is this is linked to another project, another European project that we have in our building related to cybersecurity. So we have connected just to have more complete information. Okay, so in this part is where you can see the real state of the PV plant. You can access the information in different levels, the whole system, for inverter, for string, and for module. Starting by the system, you have some features, like you can change the local time to visualize the data. You can change also the screen of the time screen where the data is shown. You can change it using this. You can toggle on or off the consumption, because for our purpose, it's not so useful. So if the load core is bothering, you can switch off. And you have a different visualization. This is the mean power generated. You can also show the accumulated energy production through the day. And you can see the instant power. In this card, we can make it bigger. See with more detail. In this graph, we are watching the instant power generation, the digital twin, and two of the inputs that are that have more weight on the digital twin calculation, as the air temperature and the compatible irradiance. That way you can deselect and see the difference. We have yesterday a problem with the data. This is related to what Van Kai was saying, the nightmare of the IoT. sometimes we have some problems with Taigo platform to get the electrical measures, but we have developed some software to recover the afterwards when we notice that we have a gap on the measures, we can recover this because we have two different sources of data. One of them is the Campbell data logger, where all the weather sensors are connected, and also the inverters. So as a data logger, you can ask for previous measures if we have some problem in the real time. And the other source of data is the Taigo platform, the Taigo cloud platform that allow us to get the data as a data logger. Okay, so this is related to the whole system. We can have more granularity if we choose the inverter level. Okay. By default, you see the same information because by default, all the inverters are selected. So all the data is summed up, but you can deselect and shows whatever you want to see. We have a digital twin for the whole system, for the inverter, for the string, and we are working right now on the module level. It's not integrated yet in the platform. You can select all the inverters that you want to analyze. And also you can choose between an aggregated view or an stack view. In this case, if you choose a stack, you are going to see separate curves. It has more sense if you choose the mean power view, because you can see the mean generated power by inverter. Inverter 9 is not working right now. We will be explaining that. Okay. And also, you can access to the accumulated energy through the day. You can select all the inverters and see which are generating more than others. If you choose the string level, it's the same, but with a higher granularity. Right now we have selected all the strings, and it's the same. You can access the same data, but with more detail. And finally, you access to the module level. This is a little bit different because as we have 108 PV panels and also their digital twins, there is too much data to show in a same graph. So we have simplified this view, and you need to firstly filter by string. You select, for instance, this. A string, you can access to the data of this string, and the second filter allows you to choose which PV panels do you want to see. And regarding PV panels, you can access to power, energy, per hour, generated per hour. This is as the LIGO optimizers that each PV module has connected. They are wireless. So this is a measure of the strength of the signal to know if there is enough connectivity between them or not. Voltage of the panels. Okay. So through this window, you can access to a lot of data. And even you want to personalize some of them, for instance, we are going to choose something more explicit like this. If you click here, you can access the whole tool to visualize every data that we have in database. You can change the zoom, for instance, manually. And also you are able to create some graphs. But well, these ones were previously configured because are the most useful for us. And if you select the data that you want to watch, you can also download it in CSV format. This could be useful for some of you if you want to download real data from our demo site. You can access the platform whenever you want. Ask for the data that you need and download it in CSV. If you want some specific graphs or data, you can access by here. And in analytics, you can enter Load Curvature. You can create a new one. There is a lot of details here to know, but you can put a name on your work, some kind of description in order to find it if you want to access another time. Private, no, profile. You can choose this is related to the resolution of the data. For instance, if I choose daily, I will be able to choose for a resolution of 1 minute, 15 minutes, 1 hour, for instance. We can choose 15 minutes. Begin date. Yesterday and today, for instance. Relative time from, you can, well, I think that you can use one or the other. But as we have set the begin date and the end date, we don't have to choose anything here. If not, you can select. I want to visualize the data of the current day till 1 week or whatever, because you are able also to watch data from forecast, if it makes sense. Okay, once you set the window, the time window, you can add data. For instance, voltage, criteria type. You can select measure, forecast, theoretical, orders. These are different kind of things, but we are focused on measures of the real installation. So maybe I can choose which one? Field level
Like
installation.
search, maybe it's a quick search. Without.
Okay. But I think that a manual to use this.
Quick search.
Okay. If we search, we are going to be able to okay. So we have found a bug. Well, anyway, we can. We will try one more. The installation is related to the device that is the source of these measures. Okay, it seems the filter is not working properly. We can try after if we are able to access. Maybe we can use a previous one to show how it works. For instance, all these are cards that have been created with this tool, and you can access to watch the data or modify something. So, for instance, we have our analyzer. You should be able to make something like this. To choose a specific telemetry for an installation to access the data. We will see if there is some more generic. Okay, but we will continue. There is still some things to debug related to that tool. Okay, so we have take a look at the graph features, and right now we are going to take a look at the other parts of the platform. For instance, we have developed a framework about alarms and alerts. You can see a summary here, but also you can access through this menu. Alarms are the rules that you have defined and you want to be running in real time about the performance of the building, of the PV plant. You can select over a specific telemetry which threshold do you want to set and which behavior do you want to have for this alert. You can define it for almost every data in the monitoring system. For instance, we'll take a look at one of them. This is related to potential power, and you can change the threshold and also the email that you want to. You are able to send an email to the person in charge of the maintenance or to somebody who has concerns about the behavior of the PV plant. And when this alert arrives, an email will be sent to that person that can be the operator. So if something happens, it will be aware in no time. The soon, the better. Okay. So I think we can see this better in the main screen. I think that it's better to explain that with the current alarms that we have right now in the reality. Okay, so these panels are shown in red, and it is because they have some problems. For instance, if you click, you have more detail about what is happening. In this case, the problem is that the panel is not communicating. We have communication loss with the optimizer, with the Taigo optimizer. We have set a different alarm for each of the 4 data that this optimizer provides us. That's why we can see the one alert for the power, the signal strength, the current, and the voltage. But if you take a look at the other one, it's a different alert, it's down. What is happening here? Well, in July, we have a problem with one of the modules from Apollo that we think that due to high temperatures, it broke suddenly without any mechanical shock. It was only because of the temperatures. So this panel is completely broken. I think that in the video you can slightly see that this panel. And as it is part of this string, we have problems with the inverter. So the rest of the modules of this string is not working. We can cross this information with the system view of Taigo in order to see if we are detecting properly what is happening in the PV plant. This is the module broken, and the other ones are connected, are communicating, but they are not producing because we have this problem with the inverter. And the other alert that we have is this specific module that is not communicating. We have noticed it and sent a notification to the maintainer, and they have to review it in order to see what happened, but it's the optimizer that is not sending any information to the system. Okay, so this is very useful to see which of the panels have some problems, and in the alert summary you have more detail. As we have said before, this inverter, the inverter 9, is not properly working. It's the one that was connected to the module that is broken. So this is why we have this alert. Also related to the string, it has raised an alert related to the string. Also, an alert for each of the modules that are not producing. And what is our purpose with all of this? Our purpose is to have to be aware of failures in the system as soon as possible. So the idea is something is not running properly in the building. It raises an alert immediately. It is shown in the platform, but we can think that the operator is not watching in this specific moment. So an email is sent to the person in charge. And also we can edit this alert and we are able to create a work order related to that alert. The next step will be that this work order can be created automatically by the platform. Right now we are doing this manually, but the idea is you can select who's going to be informed about this work order, for instance. Yes, for this demo. Select which is the type of alert. For instance, data logger communication failure. It's a work order related to operational maintenance. We have some categories here depending on the importance of the failure. And it's related to predictive, preventive, or corrective. In this occasion, is something corrective because it's something that already has been failing. And you set a limit date to have this review. The status requested, because I am launching this work order right now with an urgent priority. The location, for instance, the inverted rate, whatever, is a text. You can add useful information here. Okay, you save changes. Okay. So we have applied a work order to that alert. We're going to reorder everything. Then here I can see the work order I have just created. So if I am the operator and I have received this notification, I can enter the platform, see here, and access to this work order. And the first thing that I'm going to check is this part, recommendations. And you have some recommendations about how can you solve this problem. For instance, if the data logger is not communicating. So firstly, check if the power supply is okay, if the LEDs are blinking, and then check the cable connection between the router and the switch. Check the 3G connection and so on. Try to ping the IP address. Each of the work orders will have some recommendations in order to ease the process. And once it was requested, so once it is executed, I mean, I have entered this work order and I have fixed the problem. So I leave it as executed. And now the platform is asking me which of these steps has been more useful. Have you solved the problem by checking the supply, by it was the cable, or even if it's not any of these recommendations, you can enter which has been the solution. Open. And save. So next time I will have the same failure. I have some recommendations based on previous failures. And also, it is not developed yet, but we are planning to show here a percentage of. Oops.
No. No, save change.
Yeah. But the idea is to, based on the feedback of the operator, you are going to see the first time you face this problem again. For instance, if we change of the person who is in charge of this PV plant, the first time the person in charge face this problem, it will have a percentage of the how many times this recommendation has solved the problem. So he will be more focused on the solution, and probably he will save time. And the more time he saves to solve the problem, the less time the PV plant is not generating at its maximum. This is the idea. Okay, so finally, you can have access to these alarms that are the rules that you can change manually. For instance, right now, I think that almost every alarm that has been set has been set with a severity of critical. And for instance, this is a alarm over a data loss of a temperature sensor. For me, this is not critical. It is important, but it is not going to affect the generation of the PV plant. So I can edit and see what is a warning and say the behavior of this alarm. So next time I can prioritize which events are more urgent than the others. The same for work orders. You can edit them. You have two of them. You can access by this menu and change whatever you want to change about it. And I think the last part that we need to explain today is the analytics. Okay. We have take a look at load curve tool, but we have some problems with the filter of the telemetries. And we have also a screen related to KPIs of the system. For instance, we can take a look at the performance ratio at different levels, system, inverter, string, and the same as in the main page. You can choose which elements do you want to show. And if you want to visualize it, aggregated or stack. There is only one, so that's why. But I think that we have here a problem of visualization because the highest values are blocking the other ones. If I deselect, that's the reason. If one is higher than the other, it gets behind. So you can take a look at the performance ratio, the availability, normalized efficiency, the maintenance alarms that arise. This is a synoptic of the losses of the system, and also we have here. We plan to make a whole screen only with this part because there are more calculations in the backend that are not shown in this simple screen. We plan to dedicate a screen in this part in smart maintenance because this is our cleaning optimizer. what is shown here is the estimation of the soiling ratio. This is not the measure from the dust sensor. This is an estimation of how the soiling is being accumulated, and an estimation of the theoretical generation. I mean, what the PV plant should be generating if it is completely clean, and what is going to generate due to the soiling accumulation that we are forecasting. So the forecasting said that next 6th of October it's going to rain. And if it rains, it is going to clean the panel. So that's why this difference that we see before the rain that was due to the soiling accumulated, this is going to be cleaned, and it's going to be accumulating a little bit. And also the 16th of October, we expect some rains, and it's going to clean the panel. In fact, we have confirmed that this behavior is more or less accurate, because I think that it was before the summer, we had some rain from with some clouds coming from the north of Africa, and all the city was brown or red, cars, buildings, everything, and our PV plant too. And the panels were completely red of dust from the desert. After that, it rains with clean water, and it was clean enough to generate more or less as it was professionally cleaned. So if we attend to this result and also to the experience of these months, we can state that our PV plant is not need for cleaning. So maybe we can state that this is savings in terms of economic, because if you don't know that, you can clean just to try to improve the generation. I mean, for instance, in the previous plan, I was talking before in La Rinconada, the first plan that we begin to develop our algorithms before having the demo sites working properly. They plan the cleaning automatically twice in summer, for instance. But they do because they don't have this estimation. They don't know exactly how much money they will going to lose if they clean or not. So I can remember before the pandemic in Brussels in a meeting, Thorstein told me, but do you think it's needed to clean the PV panels? Because I have in my roof a small PV plant installation, and I don't need to clean it never. So I think that this tool is very, very useful because you don't need to make any you can know if it is needed or not. The problem is that to have this estimation, you need a lot of data from the specific place of the PV plant. You need historical data about weather, about rain, or for sure temperature, and you need to have a whole year of statistic data. But if you feed the algorithm with this data, you can have an approximation of the next whole year. So our next step will be to have more about this, because in the backend We have also the estimation of the economical losses, because we have a forecaster about the prices of the power, of the generation power. We can forecast the prices of the energy for the whole next year, and to have a summary of how much money are you going to lose. And also you can even change the cost of the cleaning and launch the optimizer and see when it is going to be useful to clean or not, to how much costs. So that's all from my side as an introduction of this platform. So next step, I think, is to provide you with credentials for those of you who doesn't have it right now. My colleague Alejandro Chito will provide this credential for you right now in the Teams, and you can take a look. And I think that for the rest of this part of the meeting, we can make something interactive. You can enter the platform, try to do something, I don't know, try to make some graphs for data that you are interested in. And if you have some suggestions, some problems, whatever, we can try to discuss it right now. Okay, so I'm going to stop sharing the screen, and we will provide you through the chat the URL. And also the credentials. One moment, please. We are going to take a look at the login and password. First one is the user, and the second one is the password. So let me know if you are able at least to enter the platform.
Yes, yes.
Okay. I think that as we have enough time, we are going to take a look at the graph tool, because it has failed in the presentation, but okay, but there is. We are going to take a look if we can show you how to book your own graphs.
Where do you put that?
In the chat of the meeting. Can you see? Oh, well, you were not joining, so I will write it again. I think that you cannot see the previous.
Oh, yeah, okay, okay.
Yes. And I will save this message so it's safe on the chat.
Oh, yeah. Now I know.
Yes. To try to make this more enjoyable, we are going to try to fake some failures on the PV plant. So you have to be aware in case something happens.
It's not the right things. I don't know. That's not the right reason.
Second, multi-frequency, focus.
Ah, super. Okay.
Okay, thanks. Yeah, that's the
Hello. Maybe one of you can share their screen or something because, yeah, I mean, if not everybody is on the platform. Okay,
Good
good.
idea.
Okay.
Thank you.
You're welcome. I'm trying right now to make some of the optimizers to stop communicating.
Maybe you can explain what you are doing so that
Yes. Well, this is the Taigo cloud. Well, this is one of the problems we have been facing in this development, because the measures went from Taigo platform, and every panel in our installation have an optimizer, and it's from Taigo brand, and they have a proprietary communication protocol. So we are not able to connect directly to the optimizers, neither to the data logger. They have their own communication protocol. They gather the information and send it to their cloud on the internet. And they only allow you to download the data from their cloud if you pay for a premium license. So this system is not really real time. We have been experiencing a lot of delays on the communication sometimes. But this is what we have been in this installation. It has an advantage because you have this platform. Meanwhile, you are developing your system. We have this as a reference. I can have a source of truth to see some way of what is happening in the PV plant, and then to check if what we are showing in our platform is correct or not. So as right now, I don't know if we are going to be able to do something physically in the PV plant. I was trying to erase the configuration of one of the optimizers, deleting the serial number. That way, the cloud, the platform is not going to match the data when it is going to receive it, and it's not going to send to us either. So we are going to detect it as the optimizer is not communicating. But this is very slow to send this notification.
You mean you are using this Taigo as a comparative benchmark?
Yeah.
Yeah. Okay.
Yeah. Because this is a commercial platform.
Okay.
And it is developed for their own devices, so this is
Okay.
very stable. But we know if, for instance, you can see here that the alarms that we are showing are the same, because this is the broken panel that it shows that has no data, and these ones have no production, that are the rest of the string. And this one, the C3, is also showing an alarm in our platform because it has no data. The optimizer is not communicating. And that's all. The rest of the panels are working properly. And it's the same that we are showing here. The A7 broken panel, the rest of the string, and the panel that is not communicating.
So this platform is today commercialized and used by our plant here in
Our platform,
yeah.
the Grid Pilot, not really, not like that. We have started Grid Pilot in the Fission project, as I have said before. That was for a different application, because it was aggregation of distributed energy resources. This was a pilot in Germany, in an island in Borkum, where we had some homes, and each home has their own PV plant in the roof, their own inverter, and an energy storage system. So our purpose was to foresee if we can aggregate the surplus in energy of each of the distributed resources and command it as a virtual power plant to offer energy services to the grid, to the market, not only to sell the energy, but also to support the grid stability. We have some controls, some services of peak saving, balancing the energy, and also we were doing some simulation as if we go to the day ahead market for Germany. The day before, we estimate how much energy can we send the next day, and mimic as the operator has agreed with this. And the day in operation, we have to control every distributed resource, every home, to accomplish this profile that we have compromised the day before. So this platform has things in common because all the base layers, the database, all the middleware that connect the components, this is the same. The base of the platform is the same, but we have from one side we have updated the front end with new technologies for this project. And we have also adapt what all the forecasts and all the calculations to this specific application. We haven't sold this or net efficient, but to show that we have been able to do what we did in net efficient has provided us commercial opportunities with Enel and also with Acciona. And we have hired us to, based on this, make their own application that have a lot of things in common. In this, and this platform can be applied to a lot of applications. Not only PV plants, because we can control processes and we can apply forecasters and digital twin that to some different processes.
Facility management.
Yes. Right. So I don't know if this is going to work. The big mistake for the PV panel. My colleagues are taking a look at the problem with the graph tool. So if you don't mind, we are going to reset the application, enter again, and see if it has been solved.
Can I?
Maybe my colleague, can you share your screen and try to show the log tool, and I'm going to try to do.
Okay, when I check is it working? Okay,
Yes.
but I know in the meeting
I will send you the link.
when you send him the link, I will make him as a presenter so he can share his screen.
Thank you, Jasmine.
Oh, but he should have it in his email.
He's right now in the meeting.
The microphone.
I have changed
Yeah.
his role. And share your screen.
Yeah. Eso voy a comprobar si funciona.
Okay.
Then checking.
I will try to delete.
We are not able to hear anything. I don't know if you are not talking
Oh,
or.
We are not speaking.
Oh, okay, okay. just wanted to check.
We are trying to, for one side, we are trying to solve the problem with the load curve tool, and from the other side, I'm trying to make something stop working.
That's working, but we are suffering a lot of low performance. Okay, that's working now. And there's a problem because the user we provide has not permission to create local tool.
So we can provide a new
A new
profile,
user, or
yes.
I can update to flow to create local tool. So let me a second, let me a few moments to.
Okay.
To give.
It seems that the load curve tool is now working properly, but we have provided you a profile that don't have access to create a new one. So we are going to provide new.
Or let me a second, I'm going to update the user to.
Okay.
To,
We are going to change the permissions in the platform to allow guests to be able to create a new tool. Are we able to?
No, still not. The news,
Okay.
I think it will be faster to provide a new user. Okay.
Okay.
Second. El operator user. Okay.
Okay, we are going to.
Yes, now there is some echo.
Okay, sorry. We are going to provide you a new profile in order to test the La Curve tool. A second. Okay. It has already sent it. Can I try again?
Yes, of think
Okay.
you can try now.
Okay, we will try again to create a new test. Description. Private, no. Profile. We're going to set as daily, 15 minutes. This whole week. Maybe 15 minutes is too much. 1 hour. Okay. Okay. There is I think I have a previous one, but we can change the name. Measure installation direct trust. Stability here. I am using the installation Sevilla PV. Okay, and here I have access to every telemetry in the system. For instance, people register in the building. A silly one, but only to test if this is working. They say
Ask you,
access.
stop.
Why is this showing
What's
so?
the time? You have put April to May 2019.
No. Oh, okay. I have to change.
I think invest.
So data.
Con-
Anyway, apart from these bugs that we are experiencing, I will appreciate if you could give us suggestions, because one thing is we have bugs and things to debug, because this is something that is monitoring in real time. There is a lot of things that can fail. But the other aspect is the functionality of the platform. So if you are people who have experience with PV plants, if you think that there are some tools or some the way we show the information, the way we cook the calculation, there is something that can be improved in terms of have more useful conclusions. All the suggestions will be appreciated. Finally, we have been able to show some data. Okay, what is this? The voltage of the inverter. Okay. I think we have to take a deep look at this tool in order to make it more user friendly, because it has a lot of options to use it for more complex things, like, because this is it was designed and defined to show also the forecast, the internal forecast, in case you want to keep some theoretical curves in our databases, or commands that you send to, as I said before, distributed resources, or electrical vehicle charging points, something like that. We have also all this information in database. So this is prepared to show all this information. We have to take a look at this and make it simple, more simple for the user, and to make it more stable. And related to the failure, I have asked one of my colleagues to disconnect something physically. I don't know if they are going to be able to do it, but we can spend a little more, and if not, I think we can finish the workshop. Please give us another 15 minutes and see if we are able to mimic something.
Very powerful tool.
Yes, but
Integrating data, very complicated to develop, I guess.
yes, the problem is each time we add the new features, there are a lot of things that can fail, and also there are a lot of different configurations in order to access the data. And also we have to deal with the real PV plant installation, the real communication. There are a lot of problems. Yes.
Every electrical device speaks another language, and you have to understand it. Crazy.
By the way, I will plan to focus this demo only in Seville, but I can show you in the meantime maybe what we have for the other demo sites. Yeah. All these tools need some time to be adapted to the other demo site. That's why we don't have all the demo sites with the same features, but we can take a look. For instance, oh,
9 degrees.
what?
9 degrees instead
Yes,
of.
a little bit different. This 3D model, I think it has been provided by Carcamation. They have provided us the 3D model of the building. So we have some alerts, but we haven't yet debugged the rules, because some of the rules that you state for to create the alerts can be the same, and some of them not. It depends of the installation sometimes. In this case, for instance, if you have let's take a look which kind of it's an alert about underperformance, but the threshold maybe is not the right one to set in this alert. Something we have to develop also. But you have all the functionalities. Except, for instance, if you go to KPIs, we are not this meaning optimization, because we need all this statistical, this historical data from weather and prices of the energy for each of the location. So we have Vilnius also. This is the installation from Solitech. In fact, the digital twin is working for these demo sites also. We have a model for running for Seville, Vilnius, and Oslo, if I'm not wrong. And also Toser, but we have a problem in Toser. It's that the Campbell data logger, the one that is connected to the weather sensors, has no access to the internet. So we cannot connect in real time. What we are doing is to download manually from the data logger the data and update it manually in the platform. Then we recalculate the digital twin. Taigo measures have been monitoring in real time, but we have this problem with the weather measures. The same. This is a 3D model provided by Carcamation, but it's not the BIM model. And finally, Toser, but we don't have this 3D model because this is the last demo site that we have added to the platform. Maybe we should ask to Willy, maybe he can provide the Toser 3D model. Okay. Do you think so? That really can provide us the 3D model as
Yeah, I think so. Yeah, that depends on terms of if they give us at least a rough dimension of that, we can produce a bit model.
so that's what we have right now. It is a pity that the project is coming to an end because there are a lot of things that we can make from this point, and we will try to make it anyway because this is a good point to start for a tool that can be commercialized, I think. So if you have any question or suggestion?
I have a question about exploitation. If we ask our utility companies, for example, in Geneva, big company, they have a push power plant project now. We could demonstrate to install your system.
Yes, for sure.
Demonstrate it.
I have to. I will prepare a video recording of a demo, but without the demo effect of the.
At least you give us the possibility to demonstrate.
Yeah.
I think that's very much opportunities for both of us and to explain the elements of the digitalization from A to Z, why we need monitoring system like yours, and why we get back information into the BIM model like ours in order to provide more information for desktop engineering. You are also OEM side of engineering, and we also the desktop engineering. So why we need both information, and we are linked together. That is also
to close the loop, as we were talking at the beginning of the project. Yes.
Because our digital twin, for example, is not necessary to store all the data. We need to extract only the relevant data from you and give it for engineer in the desktop office to take time to think about that, to change the PV panel, whatever, to install new one, and so on. And you are more in warning and urgency operation.
Yes, operation and maintenance. So we don't need the complexity of a whole BIM model that is more focused on the design stage. Yes, and
from our side, we need to provide engineers to help make the connection between the different components, to find the default, optimize the whole system for the next maintenance period, big maintenance period, for example. So all these things we need to bring together.
If you need to download the data, we provide also an endpoint, API.
Yes,
to retrieve the data.
I think that people from IREC is using this endpoint because they need to. They have developed also digital twin. I mean the machine learning models from the demo site, but based on simulated data, if I'm not wrong, because they don't have access to the real. But as we are gathering this real information, we are sharing with them. So we are using this endpoint, and this is a way of connecting different platforms. We can share the data that way. Because also it was planned at the beginning that we can include in our platform the digital twin model from IREC. We have our own digital twin model, but we can use both and even try to see which is more accurate and improve the performance.
I believe that, of course, at a certain time, far future, can integrate everything into one platform, but it higher complexity.
Yes.
So it's better to keep a little bit separate but giving good interface to communicate.
Yes.
I think it's better at this stage.
Okay, so from our side, that's all. If you don't have any question or suggestion.
Are there any remarks from the audience online? Besides clapping hands.
Thank you.
Okay, then I would like also to thank Ayesa colleagues for this demonstration and letting us also operating this plant. And I thank also our audience online for being with us for this workshop. And I hope you got some information, and we will share the slides with you afterwards. We will send you by email or so, or make you a link. And so then you can check. And if you have any questions, just contact Yasmin or me, and then we can bring your question to the right partner of the Super PV project.
Yes, they can also visit our website, and we are on Twitter and LinkedIn in case you want to check some details.
Okay, so then I would say goodbye and thank you very much.
Thank you.
Thank you. Bye.
All right.